Big O notations or time complexity is not only one of the most asked questions in interviews, but also one of the most asked questions on this YouTube channel. For the past couple of weeks, we have been creating a lot of shorts and reels about concepts of big O notations with examples and solving real life problems. But what we have noticed is that it maybe is unfair because a 30-second video cannot justify such a vast and huge and important topic in software engineering. That's why in this detailed video, we will be going through everything that there is in terms of big O notation. We'll start from very basics, the definitions, basic problems, to very highly advanced problems that I gathered over the years of my experience from either books, well, one of my favorite books like this one, or from what I got on the internet and other resources. And I can promise you this, that if you stick till the end of this video and understand each and every problem that I solve in front of you, and the key word here is understand, please do not memorize, do not cram, it's not gonna help you. If you understand each and every problem that we discuss in this video, I promise you that by the end, you will be able to solve most, if not all, big O problems. And even if you're incorrect a few times, you'll at least be able to understand what it is and how to calculate it and how to go through and how to dissect a problem and come to a good solution. Now before we get into it, if you're new to our channel, my name is Pranav and I'm a software engineer. I've been working here for about 3 to 4 years now here in Montreal, working for Morgan Stanley, and I run this YouTube channel with my beautiful fiancée Kritika, and she's also a technical project manager and has so much more to tell you and teach you and discuss with you on this YouTube channel itself. Both of us have a passion of learning and teaching at the same time. That's why we make these videos for free for you guys. Now without wasting any time, let's get into it. Now because on this channel we have discussed about what big O notation is, what time complexity is, its importance, advantages, etc. I'm not going to spend a lot of time on basic definitions. Now in very simple terms, the goal of big O is to help us understand the efficiency of the code as the input size increases. One of the most simple non-technical example is that if you are a car wash company and you take 10 minutes to wash one car, how much time is it going to take for you to wash 100 cars? Now, a question here to ask is that can I wash multiple cars at the same time or not? If you cannot wash multiple cars at the same time, that means it is going to take you 100 into 10, therefore 1000 minutes to wash all the 100 cars. Telling us that it's a linear relationship, it's not that bad, but it could be improved. Now we will display the same thing in terms of code and try to understand what type of code is better than the other. And because this concept have been taught on this particular YouTube channel so many times, I'm going to link a video in the description below as well as the first pinned comment, and maybe you can see it right here on the top of this video, which I highly recommend you to go and see. It's a 4 to 5 minute video which goes through a lot of basic examples, a lot of basic definitions in a fun, short kind of a way. Each concept is explained in 30 to 40 seconds and you will have fun and have a very good understanding, and then come back to this video to actually solve complex problems with me. All the best. Now for those who are still here, let's go to my whiteboard over here and start solving some complex problems together. So I'll just take a moment here and ask you a couple of questions just to make sure that you understand the basics properly. What do you think is the answer to the first one, O of 2n? Well, don't cheat. I think you already know this. It is O of n. Why? Because we drop the constant terms. And the second one is, what is O of n squared plus n? What do you think is the answer to this one? Well, it's O of n squared. Reason being that we drop the non-dominant terms. Next one might be a bit more tricky if you don't understand the basics very well. What is O of A plus B? A lot of people get this one wrong. Can this be improved? Can this be reduced to anything? Well, no. Why not? Because we don't know the relation between A and B. We have no idea how they are related to each other, so we don't know what is the more dominant term or what's the constant term, so we cannot really remove anything over here. I hope it makes sense, and if it does, let's start solving some problems. Let's start with the rather basic one. As you can see, we go through the loop twice, but it is not a nested for loop. Therefore, you might say that the time complexity for this one is O of n plus n, because we are going through the same loop twice, right? So which will come down to O of 2n, which will go to O of n because we drop the non-dominant terms. Cool? Still with me? Makes sense? Let's go to the next one. Again, it's a rather basic one, and if you saw our video or short about when to multiply versus when to add, this would be very straightforward for you, right? Because here we are going through the same array twice, but this time it's a nested loop. Therefore, saying it's O of n multiplied by n or O of n square. Enough with the basic ones. I don't want to bore you. Let's go to a more complex problem. Okay, this is an interesting one. For every time the outer loop runs, how many times will the inner loop run? Or we can basically say how many times are we going to print out the state? Well, to understand this, there are two methods. Let's do a very basic walkthrough. Let's assume the length of the array is 5. So when I is equal to 0, in this case, how many times are we going to print the statement, or how many times is j going to run? It's going to run 5 minus 1 times, right? So it's going to run 4 times. What about the next time? When I is equal to 1, how many times will j run now? Well, j is equal to I plus 1, right? So j will start from 2, then it can go to 3, then it can go to 4. So that's the total number of times j can run. Basically, we can say that now j is going to run 3 times, then 2 times, then 1, and finally 0, which doesn't really matter. So what do we understand from here? Can we see a pattern? Can we see what will happen when I is equal to 100? J will run 99 times, 98, 97, 96, so on and so forth. I hope you get the idea. So remember when I said you don't really need to cram or memorize anything? I still stand by that statement, but you need to remember this. Basically, you need to remember the mathematical statement or mathematical formula for calculating n minus 1 plus n minus 2 plus so on and so forth plus 2 plus 1. So another way to talk about that formula is we want to add all the numbers from 1 till n minus 1, right? So basically we can say it is n of n minus 1 by 2. Right? So you need to remember this one. Then this basically means O of n square, you with me, minus n all divided by 2. Now from what we have learned, we'll drop the non-dominant terms, right? So we will remove all of this, and then we also remove all the constants. We will remove this, making this equal to O of n square. Right, so whenever you have something like this, when you're calculating the sum of all the numbers till n or n minus 1, it's safe to assume that the time complexity of that question is going to be O of n square. I hope this makes more sense to you. The next one can be a bit tricky, but it is very straightforward. So we have O of A multiplied by B multiplied by, let's say, 10,000, right? We know that it's a constant term, so this should be removed. But it seems like a huge number. It seems like it will really slow down our code because we are running the innermost loop 10,000 times. What if it was 100,000? What if it was a million? Right? What if it was a billion? What if it was 100 billion? Right? So there people start saying, well, A and B, I don't know how much they matter, but this number is really big, so it must have an effect on time complexity. You're not wrong, but we should still remove it and say the time complexity is O of AB. Now, the real question to ask here is, why is that? If you remember the first 30 seconds of this video where we talked about the basic definition of big O, I told you that big O calculates the time complexity or the efficiency of the code as the input size increases. Therefore, it doesn't really matter what our input size is, this is going to be always the same, because this constant number here, no matter how big is this, does not have an impact on how big the input is. We can safely ignore it. Does it make sense? If it doesn't make sense to you, just go back 30 seconds and listen to the whole thing again. I'm sure it will make sense then. Going forward to the next one. In this example, you can basically ignore whatever is happening inside the for loop because it's all O of 1 or constant. So basically we need to just know how many times the loop going to run here. Let's take basic example. What if n is equal to 25? Well, the possible values for x are 2, 3, 4, and 5. What is n is equal to 36? Well, the possible value would be 2, 3, 4, 5, and 6. What if n is equal to 3? Now, the possible values are only 2 and 3. So, we can see a pattern here. We are able to notice that it can only run till square root of n. Right? So, this problem can actually be simplified and written like this. Therefore, telling us that the time complexity for this one is O of square root of n. So it's a very, very efficient algorithm because when it's n is equal to 100, well, it's only going to run 10 times. Okay, let's zoom in a bit for this one because it is one of the problems that I actually got wrong in an interview, and I hope you don't make the same mistake as me. So let's break down this problem and just focus on calculating the Fibonacci part. Let's try to calculate the time complexity of that. It's a recursive function, And I'll give you a hint. Recursive functions have a formula of O of branches to the power of depth. Now, taking a simple look at this code, we can tell that the number of branches are 2 because every time this recursive function runs, we are calling it 2 more times. Therefore, let's take an example. If the input is 4, it's going to divide into 2 and 3. Then 2 is going to divide into, because again, -1, n of -1 and n of -2. This is going to divide into 0 and 1. This one over here is going to divide into 2 and 1, and this one is going to go to 0 and 1. So how many branches at each level? 2 branches. Therefore, let's write 2. And how many levels did it go? How many depth did this have? So it started from level 1, level 2, level 3, and level 4. Therefore, we can say it is 2 to the power 4, and 4 was the input, so 4 was equal to n. Therefore, we can say this is O of 2 to the power of n. Okay? So this is the time complexity of just the Fibonacci part, just the recursive function. The mistake I made was I just looked at the outer loop and said, okay, it's going to run n times, and the inner one has a Fibonacci function, which is O of 2 to the power n. I just said it's going to be n multiplied by 2 to the power n. So I said it's going to be n 2 to the power n. Well, this is wrong because we need to consider how many times is the recursive function being called, which is n times, absolutely right. But each time the value of n is different. For the first time when Fibonacci function is called, the complexity will be 2 to the power 0. Second time is going to be 2 to the power 1, 2 to the power 2, 2 to the power 4. How much? So it's going to be 2 of 0 plus 2 of 1 all the way to 2 of n. And I absolutely did not know this, that this is also a mathematical formula, maybe taught in high school, but I forgot about this one, that the answer for this is O of 2 to the power n plus 1, which finally equates to O of 2 to the power n, again dropping the constant terms. Therefore, the answer is still the same. So no matter how big the outer for loop is, the complexity remains the same as if it was being called just once, which is absolutely absurd because it seems like it shouldn't be the case. It seems like the outer for loop, the new for loop in this case, should make an impact, but it doesn't because, as you can see right here, because of this mathematical formula, which most of us forget in interviews and in general, the time complexity remains the exact same. I hope this makes more sense, and take a note of this one. Okay, after going through a couple of very difficult ones, let's take a few simple examples just to bring us back into the game and boost our confidence, right? So the first one you can see here, what do you think is the time complexity of this? Well, if you take a note, A is basically irrelevant because it's not even in the loop and it doesn't impact us how big A is in terms of time complexity. Therefore, the answer is going to be O of B. Very simple. Let's move forward. What about this one? Again, an interesting one, an easy one, but can confuse a lot of people because you see two different numbers. You see A and B, right? And if you carefully notice, yes, it's a recursive function, but it is basically going from B, B minus 1, again minus 1, again minus 1. So basically it's going to, let's say if B was 10, it's going to 9, 8, 7, and finally it's going to 1. Therefore, again, the time complexity is O of B. Okay, two simple ones. Let's go to the next. Don't let this one fool you. The time complexity is going to be O of 1 because it's a constant amount of work and it doesn't matter how big or small A and B are. The next question here requires you to have a knowledge and understanding of what a binary tree is. So in very simple, maybe layman terms, a binary tree is something where a node cannot have more than 2 childs. Therefore, we can say a binary tree is when we have 4, 3, 2, 1, 0. So this would qualify as a binary tree. Is it balanced? Maybe not. Is it a binary search tree? Maybe not. We will discuss all of that soon. But we can see that this is a binary tree because each node does not have more than 2 children at every level. Now, if we keep on expanding over here, this would now become a unbalanced binary tree. What is balanced versus unbalanced? Well, if it was a balanced binary tree, each level would have equal number of nodes. But this is unbalanced because it's going longer on one side. I hope it makes sense. So the question is, what is the worst time complexity for finding a number over here? Well, as you can see, the worst case to find a number here is just to go through each and every element once. Let's say we are trying to find 10. What's the worst thing that can happen? We will go through all the numbers here then we'll come back and go from 2 to 10. Therefore, time complexity will be O of n because it cannot be worse than traversing each and every number one by one. The next one requires you to know what is a binary search tree. Now that you already know what a binary tree is, binary search tree is basically in a format where the left child is lower than the right child. That's the very basic way of explaining it, right? So let's say we have 5. On the left hand side, we can have 3. On the right hand side, we have to have a bigger number, right? It's a binary search tree. We need to have, let's say, 7. Again, following the same pattern, on the left hand side we have a smaller number, right hand side a bigger number. So let's say this is let's say 4 and this is 8. Same thing here. Let's say here we have 1 and here we have 10 or something like that, right? So this would qualify as a binary search tree. But our question here says that what if it's not a binary search tree, right? It doesn't follow that pattern. So maybe on the left we have 40, over here we can have 31, and over here we can have 111, right? Just to say that it's not a binary search tree anymore. Again, the worst case to find a number here is O of n. Why? Because let's say we have to find the number 40 or the number 10. What do we have to do? We have to go through each and every element once, right? That's the worst thing that can happen when it comes to a binary tree. Therefore, again, saying that time complexity is O of n. For this one, we again need to establish a very basic understanding of what is the time complexity of merge sort or sorts in general. Usually, if you don't have any more information provided, it's safe to assume that all sorts, and especially merge sort, has a complexity of n log n. This is a good starting point when it comes to calculate all sorting algorithms. Therefore, the very first thing we can establish as soon as looking at this code is the time complexity of sorting the array B, which would be B log B. So let's make a note here that sorting algorithms have a time complexity of B log B or n log n. Next, we have a for loop. Well, we are sure that the for loop is going to run n number of times or a number of times in this case, right? So let's say this is the for loop. Perfect. Now, another concept that you need to know about is binary search. Binary search has a time complexity of, maybe you already know, log of n. In this case, it's going to be log of B because we are going over the B array over here. Okay, so we have all the pieces of the puzzle right in front of us. Now, in case you don't know how binary search reaches log B, binary search basically divides our input every time by 2. Therefore, if you start with 100, next time you go to 50, next time you go to 25, so on and so forth. Therefore, whenever we divide something continuously, it's log to the base 2 of n. I hope that part is clear to you because I did recommend you an introductory video in the description below and the comments below, and I also mentioned that in the first 2 minutes of this one. Now, combining all the knowledge we have gathered until now, we can say that our time complexity for the for loop is going to be A multiplied by log of B, right? Plus, because we also have an outer loop, it's going to be O of B log B. So this is the final answer. This is the time complexity of the problem right in front of us, giving us the answer of O of A log B plus B log B. Now I have a question for you. Can we break down this answer over here into more simpler terms? The answer for that is unfortunately no. Why? Because again, we do not know the relationship between A and B. So this is the best answer we can have, and this is the best we can break down this problem into a time complexity. I started this video when there was still sun outside, and now it's almost night. It is 10 p.m. at my time. So I really hope this video helped you and clarified some of your questions. Please share this to all your friends who want to learn this topic or are going for interviews and do not understand time complexities completely. I really hope this helps all of you. And remember, practicing is your best friend, right? The more you practice, the better you will get. Now you have all the basic understanding of what Big O is and how to approach a problem, right? How to break down a problem, so on and so forth. But I really suggest you to practice more, solve more questions, ask me all your questions in the comments down below. I promise you that the comment that gets more than 20 likes will be selected and I'll make a video on that. So let me know in the comments down below what other topics would you like us to cover. Thank you very much for sticking till the end and see you next time. Bye.